Hey everybody, this is Larry. This is day 22 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, balanced binary tree. So I do self and record these live, so if it's a little bit slow, feel free to fast forward. I go through my thought process as I solve the problem and then go for the solution at the end. So let me know what you think. Okay, so determine this height balance. For this problem, a height balance tree is defined as every node a binary tree in which every level of every node differ by height by no more than 1. Okay. I mean, this seems straightforward, maybe? It's just thinking about the invariant and it's about the recursion, and they totally tell you that every subtree has to hold this invariant in which the height is no more than 1. So it just becomes an implementation detail, and you really, for these problems, you want to do in one recursive step or one recursive function anyway. You could do multiple passes, that's okay, but if you put another recursive function inside your first recursive function, then it may become n squared. So you do want to do this in linear time, even though n is only 5,000, because it probably can. Well, basically here we just have yeah, I mean, I think we just want to return two things. That would be, what I ask myself when I solve these problems is that for each node, what do I need to know from its child, right? Here I need two things. One is the height of that child or subtree, and two is whether this condition has held on, right? So with those two things, I think we can do it. I'm going to call it depth first search, though it's not really a depth first search, it's just recursion. So maybe let's just go, yeah, let's go, it's balanced. Maybe we even use this definition, but we also want to store the height. So let's get its balanced helper, say. Node, if node is none, then by definition, we can just say, by convention rather, that is true and that the height is 0. So we want this function to be clear of what we want to return. We want to return a tuple of, and I'm doing this as a shorthand, but if you want to write clean code, I would recommend looking up in Python anyway, a named tuple, which allows you to use it like an object. In different languages, you can return objects in different ways, so definitely do that as a wrapper. But here is just for me being lazy and keeping it short. Maybe in the future I'll change that up, but for now, that's what I'm going to do, which is return of whether the subtree is balanced and the height of the subtree, right? Okay, so then now we have, we do things on the left and we do things to the right. So I just say left is balanced and left height is equal to is balanced helper node dot left. Right is balanced right height is equal to is balanced helper node dot right, and then now we just have to put all these things together, and it looks, which is that every node different height by the subtrees of these heights differ by no more than 1. So then basically we just check if let's put it another way, right? Node is balanced is equal to, so in this case left has to be balanced obviously, and the right has to be balanced, and this condition where the left height, the difference between the left height and the right height is less than 1. And then from that we can just return this new tuple, which is what we want the answer to be, or this object. Let's call it an object. I know that this is tuple in implementation, but we just want to return an object. And then the new height of the subtree is just 1 plus the max of the left height and the right height, right? So then now we can call off the is balanced helper from the root. We only care if it's balanced, so balance, and then the second thing is just the height, which we don't need for the problem, at least not at the very top. So yeah, so then I think this should give us close to the answer, if not the answer. So I'm just gonna do some testing by copy and pasting and emptiness. Okay, so this looks good. So one thing that I would make sure and pay attention on is that because the answers are true, false, and we don't have three answers, it's very easy to accidentally get it right, even when the code isn't right. So I would advocate, just doing more test cases, going through edge cases and stuff like that. In the interest of time, I'm just going to submit because this is just a stream. So let's see if I get it okay. Yeah, so it looks good. Feels good too. And what is the complexity of this, right? Well, because we look at each node once and only once, and we do a constant number of operations for each node, it's going to be linear time, right? Constant time per node, and node, linear time. In terms of space, it's going to be, you're going to incur some space costs per iterate per recursive step, and that's going to be your maximum memory usage. It's going to be the height of the tree, which is O of h, which is in the worst case, of course, O of n. So that's basically what I have for this problem. I think the tricky part is thinking about invariance, and I think one thing I would like to point out for problems like this is that a common problem that I see, or a common question that I see people ask on my Discord channel, for example, is that they try to separate. They have these ideas in the head of the, that you have two questions you have to ask for each node, right? One is whether it is balanced, and the other is the height, and they kind of separate them into two functions, and therefore, like maybe here instead of combining together, you call another function that goes, okay, get the height of this node, and then because of that it becomes n squared. So I think this is just something to think about in terms of like combining the conditions and invariants in a way to group them together. So that's all I have, and I would also say that I have a lot of practice with this. So I know that maybe I don't want to make it sound like I'm bragging, but like maybe I made this look easier than it is. It's okay to struggle. I definitely struggle with this problem, which is not this particular problem, but these kind of problems for a while, until I realized that the key to solving these problems is to do them at the same time. But I would also say, if there's actually another way to do this, which you are able to do it the more intuitive way, which is that, okay, so now instead of returning both these things in one function, you can actually do this way where, okay, left height is equal to get height of the node.left or something. But what you have to do is just make sure that you memorize that function, because as long as you memorize that function, then you don't do that repeated loop that makes it n squared, where if you have a linked list, it becomes n squared, because then now you go, okay, the first, the top of the tree that operation takes n times, and then n minus 1 times, n minus 2 times, and then becomes n squared. But if you cache it or store the procedure, then it becomes O of n. It's not a preferred solution, but if you're doing like a time test, or if you just have no idea how to do it otherwise, that's how I would get at least getting an answer out, even if it's not the cleanest. Yeah, that's all I have for this problem. Linear time, linear space, or height, O of h space for height. Let me know what you think. Let me know what you struggle with. Let me know your let me know if you need anything with this problem, and I will see y'all tomorrow. Bye bye.